work. We're not going to do that, so let's just jump it. Okay, so here we have question 2. Now we're entering into Newton's laws. So here you have to have a better understanding of how to calculate acceleration, how to calculate attention from grade 11, because this is a grade 11 stuff. So it says an 8 kg block is being pulled by a constant force. So here you can see the force that's pulling up a rough inclined plane. So remember, here they set a rough inclined plane. So who can tell me what does that mean? So you have rough inclined plane. So there's another force that is going to be here. What's that force? If it's a rough inclined plane, what's that? Anyone? Okay, feel free to comment below. But there's a force, which is I don't want to tell you. You will comment there. Okay, so rough plane at an angle of 30. So you have your angle here. You have your angle here is 30, and then to the horizontal at a constant speed. Okay, so 8 kg being pulled by a constant force up a rough inclined plane at an angle of theta to the horizontal at a constant speed. So this tells you again that there's something that's happening. So since this is moving at a constant speed, what's happening then? So if something is moving at a constant speed, acceleration of that thing is equal to 0. So therefore the F net of that thing is equal to 0 also. Okay, so here let's take a look at 2.1.1. It says state Newton's first law in weights. So an object at the rest will continue being at the rest unless there's a resultant force acting upon the object. Okay, an object will continue moving at a constant velocity or will stay at the rest unless there is a resultant force acting on it. You see, so this is a Newton's. You just state this is something that will take you less than a minute, and then after that they give you 2 marks. Okay, so the next question, it says now let's copy this because we're going to run out of space here. I just have to copy, then we go here, we find here we have a space, then we're going to do the next question here, paste this here. Okay, so let me just put it. Okay, so the next question, it says draw a labeled free body diagram for block P. So block P, since it's moving with a constant velocity, and we know that an object that's moving with a constant velocity, the forces are balanced, then here we're going to have the opposite force, which is F applied. We're given that, and then on this direction we're going to have F, G parallel, remember, and then another thing that you're going to have is a frictional force, and then here you're going to have FG perpendicular, and then opposite to that you're going to have a normal force. And if you don't know how to draw a free body diagram, as I told you, here we're just doing a recap. Please go and watch my last videos on how to do all of those things. Okay, so here they give you 4 marks. One is for this, one is for normal force, one is for frictional force, and one is for FG parallel and FG perpendicular. These 2 things are one and the same thing. So now let's move on to 2.1.3. It says the kinetic friction force between the block and the surface of the inclined plane is 20. So frictional force, the frictional force is equal to 20.37 Newton. Okay, so which is this frictional force? Calculate the magnitude of F. So that's easy, right? It's easy, because here we know that since this object is moving at a constant velocity, if it's moving at a constant velocity, this force here that's going upwards is equal to anything that's going downwards, and this force that is going upwards is equal to anything that's going downwards. So that's easy. It's easy for you to calculate. So you can just say F is equal to F, which is a frictional force, plus Fg parallel. So what's the reason then? Acceleration is 0, because acceleration is equal to 0 and F net is equal to 0, right? So that's your reason. You can say these things are the same. Okay, so what's F, and then what's Fg parallel? Fg parallel, since it's going to be the horizontal component, so it's given by this Fg parallel is given by mg sine of theta. If you don't know how to find that, please just watch my last videos where I do Newton's laws. You are going to learn how to do that. So we have a frictional force plus Fg parallel, which is mg sine of theta. Here you're just collecting the free marks. So F is, you take this what you're given, which is 20.37, and you add by mass of the object, which is 8 kg, you multiply by 9.8, and then you multiply this by sine of 30, because you're given that. Okay, so you just find your F here. So what's that? Let's go to our calculator. Then here it is. There we go. Then we take our calculator. Let's take our calculator to this point here. So what we have a 20.37 plus let's just open brackets so we don't confuse ourselves. 8 times 9.8 times, we have a sign here, sine of 30, then close second brackets. Okay, so it's equal to, or you see you have a 59.57. So there you go. See, so this newtons. So that's your answer for F. So do you see that's easy? You got your answer here. Then let's move on to the next question. Okay, so since we are running out of space, but now I'll just wrap. Let me just wrap this. Okay, so don't panic when you're writing your papers or your final paper or something like that, because it can affect you psychologically. Okay, so this says the kinetic friction force. Okay, we're done with that. The force F is now removed and the block accelerates down at the plane. The kinetic frictional force remains this. So now the force is removed. So what you are left with the frictional force. But the frictional force, remember, if object is going down, the frictional force is pointing up. If object is going up, the frictional force is pointing down. So don't be tricked. Here this is going to be Fg parallel, and the frictional force now is going to go to this direction. Alright, so since the object is going down, so that tells you that this force that's going downwards, this one, Fg parallel, it's greater than the frictional force that's going upwards. So it seems like the object is here, so two people are pulling. This John here pulling, and then this here it's Anna pulling. So that means Anna has more power than John, therefore this will go downwards because Anna has more power than John. So if John has more power than Anna, this will go upwards. So you see that's why I'm saying that the Fg parallel is greater than the Fg it's greater than the F frictional force. Okay, so since the frictional force remains the same, so still frictional force is going to be 20.37 Newton. Okay, So but now there's acceleration. They're saying calculate the magnitude of the acceleration of the block. Okay, so since here this is the case, we're going to say F net is equal to Fg parallel, since that one is greater than Fg parallel, minus frictional force. You take the bigger one, you subtract the smaller one, because this is greater than, it's going downwards, and that's going upwards, then it's minus. Okay, so you can take that further by saying F net. We know what's F net. F net is given by mass of object multiplied by acceleration. So now you can take it further by saying mass multiplied by acceleration, which is F net, is equal to Fg parallel minus F friction. So Fg parallel, you calculated that in your last slide. Okay, no, I wrapped that. And then here you are going to say this mass, you have it is 8 times acceleration. Fg parallel, you're just going to do the same thing, is still mg, the sine of theta, minus 27 minus 20 is 20.87. you see. So here you have your 8a is equal to mass, which is 8 multiplied by 9.8 multiplied by sine of 30, then minus 20.37. okay, so let's bring our calculator again. Okay, our calculator, it's here. Okay, so we're saying that we have 8, let's just open brackets, 8 times 9.8 times the sine of 30 minus 20.37. so you have 18.83. so here you have 8a is equal to 18.83. and then when you divide both sides by 8, now this is your answer, you divide that by 8, and then you get 2.35 meter per second squared, which is going where? Down the slope. So that's your acceleration, 2.35 down the slope. Okay, so that's easy, right? It's easy. Even a grade 7 learner can do that. That's easy. So let's move on to 2.2. I will just rub again. We're moving on to 2.2. Make sure you understand. If you don't understand, pause the video and try to analyze how I did it. Okay, so 2.2, it says a 200 kg rock lies on the surface of the planet. Okay, so on the surface of the planet, the acceleration due to gravity on the surface of the planet is, so acceleration due to gravity on the surface of that planet is 6.0 meter per second squared. And this is the planet here. So you have a rock here, it's going to be your rock. This is a rock here. So it says state Newton's law of universal gravitation in weights. So we know that that states as every object in the universe attracts each other with a force that is directly proportional. It's directly proportional to the product of two objects. Directly proportional to the mass is directly proportional to the product of the masses. Sorry, the product of the masses and inversely proportional to the square distance between the center. Distance between the center. The center. Okay, so this is a Newton's law of universal gravitation in weights. So in simple ways, in formula, in mathematics, is just G. It's directly proportional to m1 m2 over r squared. So you're supposed to learn this in grade 11. Sorry. So in grade 11, it's where they teach you Newton's law of universal gravitation. So this is the formula. So this formula says that this F is directly proportional to the product of the masses and inversely proportional to the distance, to the square distance between their centers. So you have to know that, and not to know just to cram it. You have to understand it, because the F is directly proportional to the product of the mass and inversely proportional to the square distance between the centers. So F is directly proportional to the m1 m2 and inversely proportional to the square distance between the centers. So that's how you can you can state it. So 2.2.2, it says calculate the mass of the planet if the radius is 700 kilometer. So that's easy, right? It's easy, because as we know that F is equal to G m of the object multiplied by m of the planet divided by the r squared, which is r between the center of the object and the center of the planet. So what's F? F is the same as the Fg. So this F here, this F is the same as the Fg, because the gravitational attraction. So this F here is going to be mg, which is equal to gm big M divided by r squared. So you can see that these will cancel that, right? So the m of this object, because what's the weight of this object? Weight of this object is also given by mg, as we said, and this is the same as weight. So that's why you have something like that. So now weight was given by mg. Then now we're going to be left with G is equal to G, which is a gravitational constant, multiplied by m of the planet divided by r squared. So what they ask us to calculate here, the mass of the planet, right, which is this. So we can just make that the subject of the formula to facilitate things. So m is just going to be, when you take this, you multiply by that, is G r squared and divide by this G here. So m is equal to, you substitute, which is 6 r squared. You have to change, since r was given as 700 kilometer, you have to change this to meters. So you just multiply it by 1000, which is 10 to the power 3. All right, so here you have if this plus 2 zeros is going to be to the power 5, you have 7 times 10 to the power 5 squared all over G. So G, remember that is 6.67 times 10 to the power 11 minus 11. I can't write in there. Let me open up a space. It's going to be 7 times 10 to the power 5 squared divided by 6.67 times 10 to the power minus 11. Okay, so now I don't think my calculator will be able to do this, but let me just try. Let me just give it a try. So m is equal to, but you can calculate it by using your calculator. Just punch this in your calculator. You're going to get 4.41 times 10 to the power 22 kg. Right, so this is going to be your answer. Then we're done with question 2. So I think we're running out of time. We just have to hurry a bit. Okay, because now already spent 34 minutes. Okay, so let's go to the next one.